Hello again. We're figuring out how to figure out determinants. We did a 2 by 2 and now we're going to do a 3 by 3. Before I begin, I should preface that there are actually other ways to figure out how to find the determinant of a 3 by 3 matrix. In my head I use expansion by minors, but a lot of students don't like doing that. That's basically eliminating terms and then using a coefficient in front of, a scalar in front of each 2 by 2 matrix. It's very difficult for students to fathom that formula, to understand that formula, and to apply it correctly. I do it, but that's different though, you know, whatever. One way that I do find that works with students is this way. And when you do it this way, it tends to be a little bit easier. Calculator is probably the easiest way, but I don't recommend that. I think you should always try to do everything in your head as best as you can. But if you have to, you have to. So if you want to figure out the determinant of a 3 by 3 matrix, it's not where you can just multiply this diagonal by this diagonal. It doesn't work because now you're forgetting these 4 terms there. The easiest way that I like doing it is something called diagonals, at least teaching it that way. So here's what I do. I rewrite the first 2 columns. So I'm going to rewrite this column, 1, 2, negative 1, and I'm going to rewrite this column, 0, 3, 0. And I mean, if you're looking in your own book or you're referencing something, you can do the expansion by minors method, and you're going to come up with the same answer, and it's fine. I just think this way is easier. So here's what you do. If you want to do diagonals, you multiply these 3 together. 1 times 3 times 2, which is 6. Now this is in order to figure out the determinant. I should preface though that you should write out the first 2 columns, rewrite the first 2 columns in order to do it. Next, what you do is you take this diagonal. That's why it's called by diagonals. 0 times 4 times negative 1, which is 0. And then 5 times 2 times 0, which is, I'm so glad I put those zeros there. It makes my life a lot easier. Plus 0. Now here's what I have to preference. You have to do the diagonals in one direction and do the diagonals in the other. Some people say, well, how do you know whether to stop, why to stop at 3? It's very easy. I took 1, 3, 2, 0, 4, 1, 5, 2, 3. There is no other diagonal that you can take that has 3 terms. 1, 3, there's nothing there. So you're done. You did all your diagonals from this direction. You do this direction first. Put it in parentheses, and you're going to take the difference of the diagonals going in the other way.
May I have your attention, please? Jean Herzlinger, please dial operator. Jean Herzlinger, please dial operator.
Just got the momentum going, and then it just takes it away. No, I'm back anyways. So we're going to do the diagonals in the other direction now. We did it from left to right, now we're going to do it from right to left. You can't start here, you can start there. 5 times 3 times negative 1 is negative 15. Plus 1 times 4 times 0, 0. Makes it so much easier when you have a 0. 0 times 2 times 2, which is 0. So, done. Now, add up the quantities. 6 plus 0 is 6. Subtracted by negative 15 plus that is negative 15. 2 negatives make a positive. Your answer is 6 plus 15. This is a terrible joke I tell whenever I get this as an answer. The answer is 21 Jump Street, which is a famous show with Richard Greco and the less famously known Johnny Depp. Nobody ever gets that reference because it's too old of one in my classes. But that's the answer. So that's matrices, determinants, 3 by 3. Hopefully that was helpful. Do it by diagonals, in my opinion. It's the easiest way. Write them out. Write out the first 2 columns. Diagonal, diagonal, diagonal. Add them all together. Subtract it by diagonal, diagonal, diagonal. Figure it out. Put it together. You got your determinant. You can have an inverse if you have a determinant. If your determinant is 0, you won't have an inverse, which we'll get to later. Okay. Have a good day for now. Goodbye.